Awesome. Well, first, thank you for everyone for hanging around this long. I'll also make sure to keep this short and sweet, and I will be starting it off with a bit of an overview of what Moondream is. So, Moondream, we are a vision language model with many capabilities. We focus, also, if you don't know what VLMs are by now, there's a bit of a write up here that you can dig into. For the sake of time here, I think that I'll just very quickly skim over it. But if you've ever used something like ChatGPT and given it an image, their multimodal AI understanding is uh, kind of handled by the vision layer. And we specifically at Moondream are creating these vision language models that are very small and can run anywhere. What that means is you don't need H100 to run our VLMs. You can run our VLM on something like a Raspberry Pi and take advantage of all of its different capabilities. So, what exactly are its capabilities? Now, we have a number of image capabilities, specifically querying. Querying is just question and answer with images. You take an image, you prompt it, you get an answer. We have captioning. We've seen a lot of folks come to Moondream for its captioning capabilities because we have spent a lot of our time making sure that the captions that we output are accurate and are completely void of hallucinations. We also have object detection. So again, promptable object detection means that you can give it anything that you can describe in natural language, and you're going to get a bounding box for that thing. It's generalized object detection and a 2B form factor that can run anywhere. And pointing, this is a capability that we released for agentic workflows. It lets you more precisely describe things like UI elements and returns the exact coordinates on the screen for the thing that you described. So it makes it very, very simple to be able to build these kind of agentic workflows. Um, cool thing again about Moondream here is that we have all of these different capabilities in a single 2 billion parameter model that you can run on hardware as small as a Raspberry Pi. There's a fifth capability that we released more recently. I think we'll just skip this one for the sake of time, but we were the first VLM to come in a 0.5B form factor. Our 0.5B VLM still does well with specifically the captioning capability and possesses all four capabilities. It's worth checking out. All right, let's move on to this next slide. So gaze detection was our latest capability. You may have seen posts about it on Reddit or Twitter, but essentially what it does is based on an image that you give it, it will predict where the person's attention, or I guess gaze, is at. This is pretty niche capability. There's not a lot of models out there that can do it. But I think that we've really just been drilling as much use and capability as we can out of the 2B form factor, trying to fit all sorts of functionality to kind of just show what's possible within the space, and how much you can really just be pulling out of the parameter size, the smaller parameter sizes. And yeah, so when you take things to the next level and run Moondream on multiple frames, you start to get some pretty cool capabilities here, video capabilities here. Since we generalize pretty well, you describe whatever you want to detect and you get an output like this. Again, keep this in mind. This is one model possessing all these capabilities. Anything you can describe in natural language, it'll do for you. It's pretty cool stuff. So fine tuning guide, what you're all here for. So very recently on our Moondream GitHub, we released our fine tuning guide. And there's two examples on this guide that we walk you through. I'm going to be doing a very short walkthrough to these two examples and leaving you all to go and kind of explore and tinker with it yourselves if you want. So yeah, just to get right into it, for the first example, we're going to be using the railway vision dataset to train the object detection capability of the Moondream model. Now, cool thing about training these small VLMs is that it doesn't require a ton of compute nor time. You can finish this specific data set fine tune on 4090 in about 15 minutes. And in this data set, it has, I think, close to 2,000 images. From each single image, they derive 3 different augmentations with like rotation, flips, etc. So it's like a relatively small data set, and it takes a very, very short amount of time to run. But as we can kind of see here, before the fine tune, Moondream is just completely incapable of detecting the crack inside of the railroad track. Now, after the fine tune, and you'll see that it's just detecting a single crack here. That's because in the data set that we use here, there was only like less than a dozen examples with multiple cracks in a single railway. So it's like a very like poorly represented example. But it starts to possess after a 10-minute fine tune, the capability of being able to start to handle these more niche, generalized like crack detection cases. So yeah, again, just a little bit of a recap. This was the fine tuning of our region encoder, which helped to make the object detection capability go from just completely unable to detect any crack whatsoever here to starting to show signs of life and improvements with just 2,000 images on this. So yeah, if you want to check out this fine-tuning guide, there's a QR code you can scan. There's also a URL to our GitHub repo for it as well. Next example here is going to be for the text encoder. For this, we're going to be using the Docky dataset. The Docky dataset is a dataset for pretty much like detailed captioning descriptions. So we already have a pretty good captioning capability in Moondream, but we want to show that like with this small and quick fine tune, you can improve it even further. So with the before here, you see that the caption, well, the most obvious thing that you can pull out from this is that it's shorter. But in the second after fine tune example, you start to see it be more descriptive, more literal, a little bit more verbiage and wordy in its descriptions as well. When it's given the exact same prompt of describe this image. So, if you want to adjust any existing capability, any specific use case, and fine tune on your own data with these different fine tuning guides, you're now able to. And we've done our best to make it extremely straightforward. The data set that we include in our repository is the Cocoa JSON format, which is pretty widely used and should be pretty straightforward to go in and set up. Now, this is a very recent release. We're actively working on cleaning things up. There's going to be a new PR that we push out just today, actually, and probably in the upcoming weeks as well, as we try to make our fine-tuning guide more extensive, more exhaustive, etc. So if you do have questions, I'd love to hear them. If you do have any issues you want to open up with the repo, please do, and we'll be quick to address. We'll be quick to improve, and we'll be quick to just make things better where we can here for you all. But yeah, I think that just about does it. If you want to revisit these slides, you're welcome to scan this QR code here and take a look through this whenever you want. I also suggest checking out our Discord if you need any support when you're trying to fine tune or if you run into any issues. I'm pretty much active 24/7 and will be quick to respond to any sort of queries or questions that you have, or even just hop on a call so that we can walk you through the process and help you get things up and running. But yeah, that'll do it. That was Moondream, the open source tiny VLM.
Awesome. Three quick questions. One, is the model architecture for Moondream publicly available?
So the older iterations, we did make it publicly available. Since then, we've kind of made some architectural changes. So our latest iteration isn't, but for people who want to learn more and kind of get started with things, they can still check out the Discover page in our docs.moondream.ai to learn a little bit more about how we started, where we started, what we built things with, etc.
Cool. Next up, can Moondream 2 not only detect license plates, but read them as well, assuming sufficient pixels are on target?
Yep, OCR is in fact a capability that we possess, and you could build some pretty cool video pipelines with this stuff. We had someone that reached out pretty recently working on like both pretty much exactly that use case, but for motorcycles, like detecting a motorcycle and then detecting the license plate if it did motorcycles detected and reading its license plate off of the motorcycle if it's visible enough. And that was kind of like a cool one that kind of just shows like when you have these small capable models, you can just use that single model to tackle all those different problems at once.
Cool. And a two-parter to close things out. Do you fine-tune VLMs with lower parameters or use transfer learning, training larger model first and then pruning the smaller models?
So, for our fine-tune guide specifically, do you mean, or do you mean generally our process?
Maybe Akashay, you can follow up with that one. His second part on the question was, are these models deployable on mobile phones?
Oh, we're actually going to be releasing a mobile client very, very soon. So if you want to be the first to know when we release it, just hop onto our Discord, which you can find the link to on moondream.ai, the website, and you'll be the first to know. But yeah, very, very soon we will be uh, releasing our support for mobile clients, and we'll have a VLM that can now run all these capabilities off of a mobile phone.